Hey everyone, and welcome back to AI Paper Podcast. Today, we're diving into a fascinating new paper that's making waves in the 3D world. RigAnything, template-free autoregressive rigging for diverse 3D assets. This paper just came out of UC San Diego and Adobe Research. It tackles the age-old problem of rigging, creating those skeletons that let us animate 3D models.
That's right, and this one's a potential game changer. We all know how tedious and time-consuming manual rigging can be. And while there are some existing auto-rigging solutions out there, they often struggle with anything beyond basic human characters.
Right, like try rigging a spider with those tools, good luck. But RigAnything claims to handle it all. Humans, animals, furniture, you name it.
Exactly. What's really cool here is that it's template-free. Instead of relying on predefined skeletons, RigAnything learns to predict joint placement and connectivity based on the unique shape of each model. Think of it like this. Traditional methods are like trying to fit square pegs into round holes, while RigAnything is like having a custom mold for every object.
Okay, that's a great analogy. But how does it actually work?
Well, it uses a combination of clever techniques. First, it uses an autoregressive model, which basically means it predicts each joint based on the shape of the model and the location of the previously placed joints. Think of it like predicting the next word in a sentence. Each word depends on the words that came before it.
So it's like the AI is learning the grammar of skeletons. That's pretty neat, but I'm guessing there's more to it than just that, right?
You bet. They also incorporate diffusion modeling, which is a technique that's been making waves in image generation.
Oh, right. I've heard of that. It's that thing where you start with random noise and then gradually refine it into a coherent image, right?
Exactly. But here they've adapted it to predict joint locations in 3D space. So instead of directly predicting where a joint should go, it starts with a sort of fuzzy idea and then refines it step by step until it converges on the most accurate position.
So it's kind of like starting with a blurry image of a skeleton and slowly bringing it into focus.
Exactly. And to top it off, they organize the joints in a breadth-first search order.
BFS. Isn't that a search algorithm? What does that have to do with rigging?
Well, it's about making the skeletal structure predictable for the AI. By arranging the joints in this way, it creates a hierarchical structure that's easier for the model to learn. Think of it like organizing a family tree, starting with the parent joint and branching out to the children. This makes it much better at handling a wide range of models, from simple objects to complex articulated characters.
Okay, that makes sense. So they've got this clever model that can theoretically handle any 3D shape. But did they actually put it to the test?
Oh, they absolutely did. They trained RigAnything on a massive dataset of 3D models, including both the RigNet dataset and a curated subset of the Objaverse dataset.
Objaverse, that's that huge 3D model database, right?
That's the one. So they really threw everything at it. Humans, animals, furniture, you name it. And get this, the results are impressive. They compared RigAnything head-to-head with other state-of-the-art auto-rigging methods, and it consistently outperformed the competition.
Seriously. So it actually lives up to the hype.
You can see it for yourself in Figure 5 of the paper. They show a side-by-side comparison of skeletons generated by RigAnything and RigNet, which was previously considered the leading method for template-free rigging. The difference is striking. RigAnything produces much more accurate and natural-looking skeletons, especially for those complex models that used to trip up the older methods.
Wait, so you're telling me I can just throw any 3D model at this thing and it'll spit out a perfectly good rig? That's kind of mind-blowing. What kind of sorcery is this?
Well, it's not magic, but it is some pretty impressive AI engineering. They even did a bunch of ablation studies to figure out which parts of their model were contributing the most to its performance.
Ablation studies, that's where they remove or modify parts of the model to see how it affects the results, right? So what do they find?
They found that each component of their approach, the autoregressive model, the diffusion modeling, and the BFS joint ordering, played a crucial role in achieving the model's stellar performance. You can see the details in section 4.4 of the paper, but the takeaway is that they really did their homework and optimized every aspect of the model.
Okay, color me impressed. But let's back up for a sec. In the first minute or so, you mentioned that this paper has the potential to be a game changer. For someone who isn't deep in the 3D world, why should they care about this?
You're right, it's easy to get caught up in the technical details, but the implications of this work are pretty huge. For starters, it means faster and easier animation workflows for 3D artists and game developers. No more spending hours painstakingly placing joints by hand.
Right, that's definitely a win for anyone working in those fields. But you said it goes beyond that, right?
Absolutely. It has the potential to democratize 3D asset creation. Imagine a world where anyone with a 3D model, regardless of their technical expertise, can easily bring it to life. That opens up a whole new realm of possibilities for fields like virtual reality education and even healthcare.
Okay, now you're talking. That's the kind of impact that gets me excited. But let's be real, no technology is perfect. What are some of the limitations of RigAnything?
Well, for one, it currently lacks fine-grained control. Artists can't specify things like the exact number of joints or their precise placement, which can be a limitation for certain professional workflows.
Yeah, that makes sense. Anything else?
Another limitation is that it relies solely on geometry as input. It doesn't take into account things like texture, which could provide valuable information about the underlying structure of an object.
Right, like if you're trying to rig a closed character, the texture of the clothing could give you clues about the shape of the body underneath.
Exactly. So there's definitely room for improvement. But even with those limitations, RigAnything represents a significant leap forward in the world of 3D content creation. It's exciting to think about where this technology could go in the future.
I totally agree. But before we get ahead of ourselves, let's dive into some of the more specific details of the paper. I want to hear more about how they tackled those ambiguities in rigging that you mentioned earlier. You know, the sibling ambiguity and the topology ambiguity.
Ah, yes. Those are fascinating challenges. Let's unpack those next. What stands out to you so far?
Honestly, the thing that really blows my mind is the idea of using diffusion modeling for rigging. It's such a creative application of a technique that was originally developed for image generation, and the results speak for themselves. The skeletons it produces are just so much more accurate and natural looking than anything we've seen before. It's a real testament to the power of AI and the ingenuity of these researchers.
I couldn't agree more. It's a prime example of how cross-pollination between different fields of AI can lead to groundbreaking results.
Okay, enough gushing about diffusion modeling for now. Let's dig into those ambiguities. I'm curious to see how they tackled those tricky problems.
Let's do it. I think you'll find their approach quite ingenious.
Okay, so you mentioned earlier that there are these inherent ambiguities in rigging. Can you break those down for us?
Of course. The first type is sibling ambiguity. It arises because when you're building a skeleton, the order in which you add joints at the same level of the hierarchy can be arbitrary. For example, if you're rigging a human arm. Does the wrist joint come before the elbow joint or vice versa? In the end, both lead to the same functional skeleton.
So it's like, does the order you list your siblings in matter? Not really, you're still all siblings?
Precisely. And this arbitrariness can really trip up traditional rigging methods, which rely on those strict predefined rules.
Gotcha. So how does RigAnything deal with that?
It takes a probabilistic approach. Instead of saying, this joint must go here, it predicts a distribution of possible locations. Taking into account that uncertainty we just talked about?
It's like it's saying, hey, I'm not 100% sure which joint comes first, but here are the most likely options based on what I've learned. That's a much more flexible way of thinking about it.
Right, and that flexibility is key to handling a diverse range of models and topologies. Now, the second type of ambiguity is topology ambiguity.
Topology, huh? Sounds a bit more complex.
It is a bit trickier. It refers to the fact that there can be multiple valid ways to structure a skeleton for a given shape. Think of a four-legged animal. You could have one root joint at the hip or two, one for each pair of legs. Both work anatomically.
Okay, I see. So it's not just about the order of the joints, but also the overall structure of the skeleton.
Exactly. And once again, RigAnything's probabilistic approach comes to the rescue. It learns to represent those different valid configurations, essentially capturing the full spectrum of possibilities. Figure 11 in the paper illustrates this beautifully. They show two different skeletons generated for the same shape, both anatomically sound. It's really quite remarkable.
That is impressive. It's like it understands that there's no single right answer when it comes to rigging. Just different approaches that can achieve the same goal. So they've clearly got some clever tricks up their sleeve to handle these ambiguities. But what about the nitty-gritty details? What makes this whole thing tick?
Well, one key innovation is their use of a hybrid attention mechanism in their transformer architecture. Now, this is where things get a bit technical, but bear with me.
All right, hit me with it. I'm ready for a deep dive.
Essentially, they use different attention patterns for shape tokens and skeleton tokens. Shape tokens leverage full self-attention, allowing them to capture the global geometric context of the model. Meanwhile, skeleton tokens use causal attention, which means they only pay attention to the joints that have already been predicted in the sequence.
Okay, so the shape tokens get the big picture view, while the skeleton tokens focus on the step-by-step process of building the skeleton.
Exactly, and that ensures the skeleton generation stays autoregressive, each joint building on the last. But there's a twist. The skeleton tokens are also allowed to attend to all the shape tokens.
Wait, so they get the best of both worlds. They can see both the individual steps and the overall shape at the same time.
That's right, and this is where the power of transformers really shines through. They're incredible at capturing those long-range dependencies and relationships between different parts of the data.
Okay, I'm starting to see how all these pieces fit together. They've essentially created a model that can see the shape of an object and understand how to build a skeleton that fits it perfectly.
That's a great way to put it. And to further boost the model's learning, they use online pose augmentation during training.
Pose augmentation. What's that all about?
Think of it like giving the model a workout. Instead of just feeding it static models, they randomly deform the input point clouds using the ground truth skeleton and skinning information.
So they're essentially showing it a bunch of different ways the model could move and bend, like it's doing yoga or something.
Exactly. This helps the model develop a much more robust understanding of how skeletal structure works in dynamic situations. Figure 6 shows the impact of this technique. The full model trained with pose augmentation handles a character in a random pose flawlessly. The model trained without it struggles to cope and creates a misaligned skeleton with too many joints.
That makes a lot of sense. The more variations it sees during training, the better it will be at handling real-world situations. Speaking of training, can you tell us more about the dataset they use?
They combined the RigNet dataset with a carefully curated subset of the Objaverse dataset, ending up with over 12,000 shapes. It's a diverse mix of categories: humans, animals, furniture, all sorts of articulated objects.
Wow, they really went all out on the data front. That's impressive. Did they talk about how they curated the Objaverse subset?
Absolutely. They were very selective, filtering out models with low-quality rigging or skinning annotations. They wanted to ensure the model was learning from the best possible examples.
Smart move. Garbage in, garbage out, as they say. Did they provide any statistics about the dataset?
Yes, you can find that in the supplementary material. They show the distribution of joint numbers across the shapes, which gives us a sense of the complexity they were dealing with. They also break down Objaverse models into different categories like humanoid, quadruped, insectoid, alien, and marine.
That level of detail is always appreciated. It helps us understand the scope and limitations of the data they used. Now, as much as we're loving RigAnything, I'm sure there are some areas where it could be improved. What are some of the limitations they acknowledge?
Well, one area is fine-grained control. Right now, artists can't dictate the exact number of joints or their specific placement.
Right, so there's no way to really fine-tune the rig to meet specific needs.
Exactly. And the other limitation is the reliance on geometry as the sole input. Texture could provide valuable information, especially when rigging closed characters or objects with complex surfaces.
It's like you can't always judge a book by its cover, right? Sometimes you need to look beneath the surface to get the full picture. So what are the researchers' thoughts on these limitations? Do they have any ideas for addressing them in the future?
Absolutely. They acknowledge both of these limitations as areas for future research. They suggest that incorporating texture information would be a valuable next step, and that developing methods for more fine-grained control would further enhance the usability of the model.
That makes sense. It sounds like there's still plenty of room for innovation in this space, but even with these limitations, I'm incredibly impressed by what they've accomplished. It feels like a major breakthrough in automated rigging.
I completely agree. It's a testament to the power of deep learning and a sign of exciting things to come in the world of 3D content creation.
Okay, we've covered a lot of ground here. We talked about the problem RigAnything solves, how it cleverly leverages diffusion modeling, and even delved into those pesky rigging ambiguities. What stands out to you as the most groundbreaking aspect of this work?
I think the most impressive thing is the sheer scope of RigAnything's capabilities. It's not just a marginal improvement over existing methods. It's a fundamental shift in how we approach rigging. The fact that it can handle such a wide variety of shapes, from simple objects to complex characters, all within a single template-free framework, is truly remarkable. It has the potential to revolutionize the way we create and interact with 3D content.
I couldn't have said it better myself. And on that note, I think it's time to shift gears and explore the broader implications of this work. What does RigAnything mean for the future of 3D content creation?
Let's dive into that. The possibilities are quite vast and exciting.
All right, so we've established that RigAnything is pretty darn impressive. But let's zoom out a bit and think about the bigger picture. What does this mean for the future of 3D content creation? Is this the beginning of the robot uprising?
Well, let's not jump to robot overlords just yet. But you're right, the implications of this technology are far-reaching. We've talked about the benefits for 3D artists and game devs, but it goes way beyond that.
Okay, give me the grand vision. Where else could this be a game changer?
Think about robotics. RigAnything could be used to auto-generate skeletons and control systems for robots, making it way faster and easier to design and build new robotic systems.
So instead of painstakingly programming every movement, you could just throw a 3D model of a robot at RigAnything, and it would figure out how to make it move.
Exactly. It could revolutionize the field, and it doesn't stop there. Imagine the potential in healthcare. Surgeons could use RigAnything to create patient-specific anatomical models for planning complex surgeries or training medical students.
That's incredible. So instead of relying on generic models, they could have a virtual replica of the actual patient they're going to be operating on?
Precisely. It would be a huge leap forward in precision medicine. And let's not forget about education and research. Students and scientists could use RigAnything to create interactive 3D models for visualizing and studying complex systems. Whether it's the human body, the Earth's climate, or the structure of a molecule, the possibilities are endless.
Okay, you've officially blown my mind. It sounds like this tech has the potential to touch just about every field imaginable. But with any powerful tool, there are always potential downsides. Are there any ethical or societal implications we should be thinking about?
You're right, it's crucial to consider those aspects as well. One concern is the potential for job displacement. If RigAnything can automate the work of human riggers, what happens to those skilled professionals?
Yeah, that's a valid concern. Automation is a double-edged sword.
I believe that instead of replacing human riggers, RigAnything will augment their capabilities. It'll free them from those tedious, repetitive tasks, allowing them to focus on higher-level creative and technical challenges. Think of it like this. 3D modeling software didn't eliminate the need for sculptors. It empowered them to achieve new levels of artistry and efficiency.
That's a great point. It's not about replacing humans. It's about giving them better tools to do what they do best.
Absolutely. It's about collaboration between humans and AI, leveraging the strengths of both to achieve outcomes that would be impossible alone.
Well said. Any other potential concerns we should be thinking about?
Of course. Like with any powerful tech, there's always the potential for misuse. RigAnything could be used to create misleading or harmful content, like realistic deepfakes or 3D models that spread misinformation.
That's a sobering thought. It's a reminder that technology itself is neutral. It's how we choose to use it that matters.
Exactly. We need to develop ethical guidelines and safeguards to prevent misuse and ensure this technology is used responsibly for the benefit of society.
Couldn't agree more. So before we wrap up, I have one final, slightly mind-bending question for you. We've seen how RigAnything can generate skeletons for existing 3D models. But what about the reverse? Could we use this to figure out the shape of an object based on its skeleton or movements?
Wow, that's a fascinating question. It's like asking if we can crack the code of biomechanics, inferring form from function. It's a tough challenge, but given the rapid progress in AI, I think it's within reach.
Imagine the implication. In paleontology, we could reconstruct the appearance of extinct animals based on their fossilized skeletons. In animation, we could create new creatures just by defining their skeletons and how they move.
It's truly mind-boggling. It highlights that we're only scratching the surface of what AI can do in understanding and manipulating the physical world.
Well, I think we've given our listeners plenty to chew on today. RigAnything is a powerful reminder that the future of 3D content creation is intelligent, automated, and overflowing with possibilities.
Absolutely. It's an exhilarating time to be working in this field. And I can't wait to see what other groundbreaking innovations emerge.
And that's a wrap on this deep dive. As always, we encourage you to dig deeper into the source material and continue exploring the fascinating world of AI and 3D. Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible.